All right, let's get started. Welcome, everyone. Don't worry about the bars closing. Those will reopen again afterwards. So don't worry. Hopefully you have a drink in hand. Well, welcome to Scala Days 2013. Let's hear it for Scala Days. Awesome. Yeah, it's going to be a great one. So this is the fourth annual Scala Days. So I wanted to see, whose first Scala Days is this? Awesome. Look at all those hands. That's fantastic. Okay, whose second Scala Days is this? Oh, only a couple. Okay, what about third Scala Days? Whose third Scala Days is this? I see like 3 people. Okay, and now, whose fourth Scala Days is this? Awesome. Let's give those people a hand for Scala Days. That's great. Thanks for being here all those years. That's awesome. Did I say I'm James Ward from TypeSafe? I'm a developer advocate there. So this conference is about you. So glad to have you here. So glad for you guys to be part of this. This is your conference. This is a conference about the community, the Scala community, and we just can't wait for you to be part of this and part of the sessions. So we have a few logistical items that we wanted to go over with you, some agenda stuff, and so I'm going to bring up Sushila from TypeSafe to give us those agendas. So let's give her a hand. Thanks.
Thanks. Oh, wow, this is fantastic. It's great to see such a good crowd. So I have the pleasure of talking about logistics, and hopefully some of the announcements I make will just make things a little bit easier as you navigate through the conference over the next 2.5 days. So, first and foremost, please follow us on Twitter. We're going to be making any late-breaking news types of announcements, celebrity sightings, all of that stuff on Twitter. So please follow @TypeSafe for the latest. Also, if you're doing any tweeting yourself, we've got #ScalaDays, so please use that. You probably have all figured this out by now, but we've got a Scala Days Wi-Fi network, so the password is Scala Days, the network Scala Days. If at any point during the conference you guys have questions, need some help, need directions, anything that we can provide for you, myself and my team are happy to assist you. Anyone who's got staff on their badge will be able to help. And then, of course, anyone from TypeSafe can direct you to the right people as well. Just regarding some of the logistics for the rest of the conference, we will be serving breakfast tomorrow and Wednesday. Starts at 7 a.m., goes to 8:30 or 9, depending on the day. But yeah, please do feel free to come down and join us for breakfast. You can help figure out the conference schedule by looking at your program, obviously. Going to the scaladays.org website where the schedule is. And just keep in mind that all the keynotes, the 2 keynotes tonight and Wednesday, are in the Hudson Theater. All meals are here in the Hudson Theater. And all sessions are in the conference center, which is just adjacent. And so we've got 3 floors in the conference center where the sessions will be held. The second floor has the Metropolis room for sessions. Room 3.11 and 4.11. So those are on the 3rd and the 4th floor. Let's see. Sessions are going to be first come, first serve for the seating. So encourage you to get to sessions as quickly as possible and find seats. There's going to be some packed sessions. We are recording all the sessions, so they will be available after the conference on parlays.com. And as registered attendees, you will have access to all the recordings as they become available. If, when you get to the conference center, you'll see that every floor has a digital board that displays which sessions are happening when. So consult the board. It'll always be updated with the latest information, as will @TypeSafe. There's also monitors outside each session room that will tell you what session is going on. So always a nice idea to just check and make sure you're in the right place. Between every session is a quick 15-minute break, and on every floor there will be refreshments available. We also have a small number of charging devices on each floor, so if you find yourself running low of power, our Platinum sponsors have generously provided charging devices. So actually on that note, a big thank you to all the sponsors of Scala Days 2013. You can see all the logos of the sponsors that have been a part of the event and just done a really good job helping us coordinate everything. I'm also going to point, yeah, thank you. That's a good idea. I'm also going to point out that there's a resources table in the back of this first floor of the Hudson, in case you haven't seen it. There's some good stuff there that you guys might find helpful. There's books available for purchase, for download, and just for free. And that's about it. I did want to just talk a little bit about the evening events. Tonight, after Martin's keynote, which we're all very excited for, as James mentioned, the bar will reopen. You can grab some drinks, and we're actually going to have a live band. And it's a karaoke band, so pay attention to Martin's keynote, but start thinking about what you're going to sing. And tomorrow night, we will make our way to the Heartland Brewery after the sessions end. And that is a party that's courtesy of all these great companies: Bridgewater, Pellucid, Novus, Tumblr, Hunch, Twitter, and Tapad. So I'm really looking forward to a fun event. We actually have rain ponchos, so I know several people got soaking wet on their way to the conference, and we couldn't quite control that. We tried to think of everything, but we couldn't control the weather. But we did manage to snag some rain ponchos, which you can pick up sometime this evening. And if it's raining tomorrow, as we just walk the 2 blocks to the Heartland Brewery, we will all be kept dry with those. Yeah, well, actually, I want to thank Empire Force Events. They've been helping us with the whole event, and you know, it was about maybe 5 hours ago that I thought, oh gosh, it's going to be tough if we're all walking to the Heartland Brewery and getting wet. Like, no one's going to be happy. If only we had some rain ponchos. 5 hours later, we have hundreds of rain ponchos to give out. So Empire has been fantastic, as has the Millennium Hotel and the Hudson Theater staff. If we run into any of those folks, please give them a big thank you for all their help with putting together the event. My last note is some excitement on Wednesday. Obviously, Rod Johnson will be doing the keynote, and that is exciting enough. However, at lunch, he is also going to be playing the piano for us. So really encourage everyone to stay for that during lunch. So that's it for me. If you have any questions, come find me. Come find anyone in a TypeSafe t-shirt. Again, anyone with a staff badge can help you. And really hope you guys have a great time. And I will give you back the floor, James.
All right, great. Thanks, Sushila. Okay, so we have a couple of little apps and things to talk to you about real quick before we dive into the keynote. So first, if you look in your swag bag, you'll find a USB key. It's kind of a dual-purpose USB key. It is for opening bottles. That's awesome. That's a good purpose. And then it also has a new product that we announced about a month ago on it, but a new version of it called TypeSafe Activator. And TypeSafe Activator is a new way to get started with our technologies, with Scala and Play and Akka. And we just released a new version that allows anyone to contribute their own templates into Activator. So check it out. Give us your feedback. It's in developer preview. We'd love to hear how it goes for you, especially for those that are new to our technologies and getting started with them. It's really targeted at that. So check that out. Okay, next up, we do have a mobile app, actually, where you can browse the schedule and do all sorts of other things. So I want to bring up Mike from Tinder. He's going to give us a quick little overview of the app. So let's give Mike a hand.
Okay, cool. Okay, hi everybody. I'm Mike from Tinder. We're a consultancy out of Canada, and we helped TypeSafe put together this app. for some previous conferences, and we're going to bring it and put it to good use at this conference. So the app's called TypeSafe Con. So if you search on your app store for TypeSafe, there's an iOS version that I'm going to demonstrate, and then there's an an Android version that has a couple less features, but has all of the conference schedule and everything you need on it. I know there's an Apple event going on right now too, where they're doing a lot of these kinds of demos. This is not going to be that good, so bear with me, but I'll do my best. So when you load up this conference app, really the purpose of the application is twofold. It's both to let you really get the most out of the conference, to organize your conference experience, and to get all the information that you need to see the sessions that you want to see and not miss anything along the way. And it's also intended to let you engage with people as you go through the conference. So when you look at this, this is the main screen of the application. And when you load up the application for the first time, the first thing you should do is fill in a profile. And the reason for that is there's a few functions that don't work unless you fill in a profile. So I'll go in and I'll just fill my own in here quickly. All of the information you put in here will be available to other people using the application. So if there's anything you don't want to put in and show people, just don't throw it in there. But you need an email account at a minimum. That's sort of the minimum to put in there. So pull this up here. Okay. There we go. Yeah.
Good choice.
Thank you. It's my favorite. Okay. So so once you've got your profile created, you can go in and have a look at the events. So under the events, you'll see all of the various different events that are going to be going on for the course of this week. And in here, you can sort of hit any event and get some details on the event. But the main thing that you can do with this screen that's really helpful is, as Sushila mentioned, there are a series of different events going on at the same time in different rooms. So you might say, oh, I really want to see this one in 411, this one in 311, and this one in Metropolis. What you can do is you can star those various different events, and as you star those events, they're going to drop into your favorites. So your favorites is intended to be like your personalized conference schedule. So you can go in there and fill in your own schedule and fill that out and see what you want to see. You can do the same thing for speakers. So if you really want to see what Dick Wall has to say, make sure you star him. He'll show up in your favorites as well. So right there. And when you go in there, you can also see the talk that he's doing and sort of go through that information. The other thing that you can do with this application is you can engage with other people who are at the conference. So there's a general discussion board that can be asked general questions and things like that. And there's also a event-specific discussion board. So on the cocktail hour, you can go in there and you can fire in a comment or whatever, and it'll go to everybody else who's looking at that board. You can also choose to send those comments over Twitter or Facebook at the same time to send those out to the world. And the other thing that you can do is you can share that event over Facebook and Twitter as well. So you can say, hey, I'm at this thing and it's amazing. You guys should be here too. The last thing I'll show you is, or the last couple of things is, if you want to engage directly with somebody, what you can do is you can actually go down and find other people who are at the event. So this will essentially load up. Now I'm going to have, unfortunately, in the same place, hundreds of people. But I can go in here and actually find other folks, and I can enter into a chat. And I can also do something called linking up. So when I link up, what that really does is when you go to a conference like this, what often happens is you go home afterwards and all you have is this great memories of this great time, but not a lot of memories of what you actually did during that great time. It's all this sort of fuzz, and as you get back down to work and get back into sort of the real world, you sort of lose that context. The idea here is to, oh, thanks for the tweet. So the idea here is to write yourself a note here that sort of gives you the ability to remember why and how you met that person. So that's just for your personal use. And what you'll get after the event is an email listing out all of the people that sent you or that you linked up with. and with their information from their profile so that you can actually connect back up with them a couple of days after the conference and get that context back. The last thing I'll say about the application, which is playing funny on me right now. So the last thing I'll say about the application is that it is an open source application. So it's all on GitHub. If you go to the playground link, it's going to allow you to have the, it'll show you the GitHub repositories. The back end's all built in Scala and Play. The front end is obviously the native applications of the various different devices. If you want to hack at it tonight or tomorrow and send us a pull request for something to drop into the playground, go for it. That'd be great. And any new functionality you want to add to the application as we go. The iOS app and the Android app obviously have some time lag associated with them for an update, so we probably won't be able to get any changes in the conference, but anything on the back end will go up. So if you have any questions or any problems with it or anything like that, just shoot us a note at info@tinder.co, and thanks very much.
Awesome. Thanks. That looks really great. I can't wait to try it on my BlackBerry. I do still have a BlackBerry. One important announcement. If you are Thomas J. Schotchurch Jr., S-C-H-O-R-I-S-C-H, Jr., any ideas on how to pronounce that? Anyways, you've lost something important. Come see me afterwards. Okay? Oh, and your lights are on. Sorry. Okay, so let's keep on moving here. So I want to bring up, of course, our star speaker, the guy who created Scala. Let's bring up Martin Odersky to start us off with something really special. So let's give him a hand.
Thank you. Wow, this is really amazing. So it's my 4th Scala Day, so I'm one of the 4 persons, and we have been to great venues every time bigger than the one before. We've been at Lausanne and then at Stanford University, so Kun Leolokotun, the organizer, is actually here. Then we've been in London and now here, but I think it's fair to say that I've never been at something as impressive as a venue as this one here. So thanks to the organizers, particularly Sushila and James, for picking it and making it all happen. Now, before I launch into my talk, and you can all safely go to sleep, there's one thing that is much more important and that I wanted to do first. Scala really is the community. That's what makes it happen. That's what drives it. And I believe there are a few people who are key to the community. And one of the people who was absolutely key as much as anyone else was Phil Bagwell. So what we wanted to do is we wanted to have an award in memory and honor of Phil Bagwell for outstanding contributions to the community. And I'm very happy to say that this year's award is for Dick Wall, who I guess all of you know, and I think who has been really the soul of Scala and the Scala environment, in particular with his emphasis on being open, on being friendly to newcomers, and on being inclusive. So Dick, please. Here we are. Yeah. So I have the pleasure to give you this plaque, which says, in honor of the late Phil Bagwell's passion, enthusiasm, and dedication to the Scala community.
Thank you very much.
And you get a watch, which is also something special because it's a high-altitude watch. So you can go very high up in the stratosphere with it. And you have to know that Phil, his favorite hobby was piloting gliders. So he would love to stay up in the air forever. And the watch is just the right watch for that. So not necessarily that you have to do it, but if you want to do it, then it's there for you.
I'll be making use of it. Have I got a minute to say?
Of course.
Oh, thank you. Okay, so first of all, thank you very much, Martin and the TypeSafe people. This is super nice, and it's actually very touching that it's in honor of Phil. I just wanted to say, I've wanted to kind of share the first meeting that I had with Phil, which was somewhat similar to the meeting that I had with Martin, in that I had absolutely no idea who I was talking to. And I was talking to this guy, and he was fantastically interesting. And I had a really, really interesting lunchtime conversation. Walked away, unlike Martin, walked away without ever knowing who I'd been talking to. And only later did I realize that it was the Phil Bagwell. I'd just never seen a picture of him before. And I'll keep this short. Obviously, you guys want to get to the main act. But one of the things that really struck me about this and various other things that I've done over the years with Java and Scala is I've met a lot of people. And one universal, well, maybe not universal, but one very, very high correlation is that the very best engineers that I've met have also been brilliant communicators. So if I'd say anything about this in honor of Phil and the other people that I've worked with over the years is next time you're picking out the technologies that you want to learn on your next to-do list, consider leveling up on people skills as one of those. Just put it in the list and get better at communicating with people. It'll make you a better engineer, I promise. Thank you very much. Thanks.
Okay, so title of my keynote is Scala with Style, and I have to admit that I've quite often already cursed the day I proposed this title, because then I had to make a talk that follows the title, and I found it very, very difficult to come up with a talk, because style, after all, is such a personal matter. Everybody disagrees with that, with each other's opinions, and it's very difficult to find something that in any way whatsoever is authoritative, that you can put forward as a measure of style that the community as a whole should follow. In Scala we have a particular problem for that, and that is because I believe that we are at this sort of confluence of two paradigms, imperative, object-oriented, shifting towards functional, and I think at the end there will be a fusion of the two. And Scala is in the middle of it. And because there are so many strands and influences in it, you have a mixture of possibilities that far exceeds a usual programming language. You just have many, many more possible choices that arise out of the fairly orthogonal combination of many different dimensions, imperative, object-oriented, and functional. And the problem is then, well, how to distill a style guide from that. Sometimes I really wished I was Guido von Rossum and I had done Python, and there was one way to do it, and that would be the end of the story. Scala is not this language, so we have to live with that, and we have to cope with it and go forward nevertheless. It's not a bad thing, because it also means that it can be much more expressive and flexible and open than a language which essentially consists of a fixed recipe for most of the things that you do. So one thing that I wanted to revisit was go back in history, because when we say that we are now in the transition of imperative to functional programming, then it might actually pay to see what happened when object-oriented programming started. And I'm actually old enough to have been around for that, not when it was created, that was before my time, but when it became mainstream, that was in the 80s. So I remember that I've seen in, I think it was 81 or 82, that this cover of Byte came out. Byte was at the time the premier magazine for developers, and I was fascinated by it. It was more than 100 pages that described Smalltalk in all the detail, everything that had been done at Xerox PARC. I was fascinated and also completely puzzled. I didn't understand a thing. Method, message, what were all these things? They didn't relate to anything that I was brought up with. Now, 30 years later, of course, all this is commonplace, and object-oriented programming has been boring, standard to the degree of being boring and enterprisey and reveled from people who say, well, it's essentially the stuff that all the bad programming practices came from object-oriented programming. But at the time, it was really the new thing and the very weird thing, pretty much like what functional programming is today. So what do you think was the first popular object-oriented programming language? And I don't mean C++ by that. Can be a little bit less popular than C++ was. So the first popular object-oriented programming language actually was Simulus 67. So 67 was the year it came out, so quite early at that. What was the second? Well, the second, I gave it away already, that was Smalltalk. So the second popular object-oriented programming language was Smalltalk. So why did object-oriented programming become popular? You could say, well, nowadays you have a zillion of books that tell you about the virtues of object-oriented programming, about all the fancy principles and software construction techniques and modelization advantages and so on. So you could say, well, maybe encapsulation, was that the secret why object-oriented programming was popular? No, I don't think so. Was it maybe code reuse? No, I don't think so either. Dynamic binding? Maybe indirectly, but not really. Dependency inversion, that one came much later. Liskov substitution principle. Open-close principle. Nah, you gotta be kidding. It was clearly because of the things you could do with object-oriented programming. There were certain things that you could do with object-oriented programming that you couldn't do before. So what was that? Well, if you look at a traditional application, like a linked list, then what you see that there are two cases of data. There's empty lists and non-empty lists, and then there's a number of operations that you can do with lists, like map or reverse or print or get an elem or insert an elem and so on. And the important thing is that these operations, they're really unbounded. You can come up with a dozen more in the next second, and it doesn't end there. On the other hand, the cases, what a list is, that's fixed. The list is either the empty list or it's a non-empty list, and then it consists of an element and the rest of the list. So that was the traditional way of looking at software. Now, if you look at the first object-oriented programming language, Simulus 67, so that was, as the name implies, for simulation, although it was a general-purpose programming language. And in simulation, you didn't have that situation at all. What you had, rather, was that you had a fixed number of operations. So, for instance, your simulation would go through the next step. You could maybe display it in some way. You could form aggregates of certain properties of the simulation. And then you had an unbounded number of implementations. You could simulate cars or roads or molecules or cells or persons or buildings or cities or anything else that you would care about. For Smalltalk, it was slightly different. Smalltalk wasn't a language for simulation. It was a language that was invented at the same time as the bitmap display and the Alto computer, and the new possibilities there was graphical user interfaces and their widgets. But the situation was quite similar to simulations, namely that you had a fixed number of operations that you could do with a GUI widget, namely redraw, resize, move, things like that, bounded rectangle. And again, you had an unbounded number of implementations. A GUI widget could be a window, menu, shape, a letter, a curve, an image, a video, and so on. Just get this up here. Whoops, sorry. So what the two applications had in common then was that they both needed a way to execute a fixed API with an unknown implementation. And that wasn't before possible, or at least not very easily, not very simply. You could do it in a language such as C, but for anyone who has actually tried to do that, it was clear pretty quickly that this would be very painful. It wasn't that people didn't try. For instance, in the end of the 80s, there was a program called the Presentation Manager that was of the IBM operating system OS/2, the windowing system, and that wasn't written in an object-oriented language, and it made you essentially go through a lot of manual things to simulate sort of this dynamic dispatch in objects. It wasn't pretty, and maybe that was also one of the reasons why OS/2 didn't win and Windows and Macintosh won in the end. So what does it have to do with functional programming? So I guess a lot of the people here in this room are convinced that functional programming has a lot of methodological advantages. Just like object-oriented programming was a step forward then, I think functional programming definitely is a big, big step forward now. I believe if you write functional programs, you will have fewer errors, you will have better modularity, you will have higher level abstractions, shorter code, increased developer productivity. But all these are, I believe, also not enough for mainstream adoption. Mainstream is something extremely difficult to move. It has a lot of inertia. And after all, an argument for that would be that with all these methodological advantages, functional programming, after all, has been around for 50 years now. It was sort of more than 50 years. The first functional language was Lisp, invented around 1960. So what I believe is necessary is a catalyzer, something that sparks the initial adoption until the other advantages became clear to everyone. And in object-oriented programming's case, that was GUI widgets. And I believe in functional programming, the catalyzer is essentially distributed and parallel programming, concurrent programming. And I believe it's driven by mostly hardware and economical forces, the hardware forces that, as we all know, we all have to go to multi-core to get significant performance gains out of the processors. And furthermore, we are running most of our applications in the cloud, which means that to get any sort of scalability, you won't necessarily run on bigger servers, you will run on more of them, and you will have to distribute your application over then dozens, hundreds, sometimes thousands of servers in a data center. And that new world has some very hard challenges. I can see at least 3 challenges there. The first one is parallelism. How do you make actually use of all these multi-cores, these new CPUs that you have in a single processor, in a GPU, in a cluster? Second one is, once you distribute, you're by necessity asynchronous and reactive, so how do you deal with asynchronous events? And finally, when you distribute things over multiple sites, then you have the problem that some of these will go down, and you have the problem that some network connectivity will take a long time or will go down. So you have all the problems of distributed computing. And these are hard problems. The issue here is that mutable state is for each of these problems a big liability, because it means that with mutable state you have to worry about cache coherence. You cannot simply cache things the last result because, well, somebody might have changed this thing on the other site, and then you have to invalidate your caches. You worry about races and versioning and many other things more. So in this new world, the standard of yesterday, mutable state, is suddenly becoming a problem. And I believe that this is, the catalyzer that will move functional programming over the bump into mainstream adoption. So the essence of functional programming, just to state it here, is that we want to concentrate on transformations of immutable values rather than the stepwise modifications of mutable state. It doesn't mean to say we will ban it outright. Sometimes there's certainly a role for mutable state, but we do not want to use mutable state without a very, very good reason of doing that. So you could say, well, what about objects? Should that go out as well with mutable state? So should we forget all we have learned about object-oriented design analysis and so on? And I believe that's probably a bit premature if we do that. And I actually don't think that we will ever forget these lessons. Because I believe object-oriented programming has good answers for some very hard questions and some very fundamental questions. So the most fundamental question that I see object-oriented programming answering is simply what goes where. In the end, with a system of a couple 100,000 lines or 1 million lines, you have to have some organization where you put things. And it's just not good enough to just put everything in the global namespace and assume that you will not have conflicts. In a system like that, they are essentially characterized by the fact that you don't even know that some components exist, never mind looking in the code. So how will you be able to avoid, let's say, name conflicts and other problems in a global namespace? I think that simply won't fly. So once you started to say, well, okay, I need some organizations, I put things somewhere, then you want to make this composition mechanism as powerful and flexible as you can, and then you will find that you want essentially first-class modules, and you want some form of code reuse and inheritance, and you want dynamic dispatch, and then you have object-oriented programming back. Whether you call it OOP or a module system doesn't really matter. But I think one point is nevertheless very important, that we will have a new view of objects, one which is quite different from what we had so far. So what did we have so far? So there's this phrase by Grady Booch which says that an object is characterized by its state, identity, and behavior. And I think he actually was wrong or no longer up to date on 2 out of 3 counts here. So the first one is state, and with state, I guess he and everybody meant mutable state. Well, I very much doubt that. That's actually the kind of objects that typically cause us often problems. Sometimes we need them, but in most cases, they're more trouble than it's worth. Identity. Do we really think it's a feature that to compare 2 strings with equals equals, we get the object identity rather than comparing the strings by value? Is that something that we want to build our software on? I don't really think so. I would say, well, it's an accident, but it's definitely not a principle that we say all objects, the primary identity of objects should be reference identity. And finally, behavior, yes, absolutely. Objects encapsulate behavior, contain behavior, so that's what we want to concentrate on. And I believe that, for me, was pretty clear and uncontroversial, and I was actually quite surprised that I was last summer in a workshop with other programming language designers, quite famous ones, some of them, and I actually met violent opposition of some of the main designers of object-oriented languages, which told me, no, I'm totally wrong, and objects absolutely need state and identity. If they don't have that, it wouldn't be an object-oriented language. So there you see, sometimes not so simple. So the question is, can functional programming and object-oriented programming be combined? And in fact, it turns out that this is pretty much a cultural problem, not so much a technical problem, because how many people see OOP is pretty much like that, like the manager type, looking over your cubicle and looking that you put the right factory in place in your code base and things like that. And it goes both ways. So the way that the mainstream industry sees functional programming is often like that. The mad scientists where they're a little bit dangerous and they're definitely crazy, and we want none of that stuff. And that's a problem, because I think we are pretty much in the middle here between those 2 communities, and sometimes it's difficult to actually have a good place to sit between those communities. Sometimes we tend to fall between the 2 chairs here. So what we would prefer, of course, is sit comfortably in chairs and lie back and be at the beach. But I think to get there, we need to work a little bit and get rid of, in particular, some baggage first, some baggage of previous conceptions in the 2 communities about each other, about what's important, and maybe also some baggage of complexity. So bridging the gap, I think Scala is really at the forefront there to try to bridge that gap between functional and object-oriented programming. And to do this, it sort of has to be orthogonal, expressive, and unopinionated, because by bridging the gap, it means that you need to be very inclusive. You need to have a large span of possibilities that you can do. So you shouldn't be too closed-minded about enforcing exactly one way to do things. So Scala naturally adapts to many different programming styles, and that's good. But on the other hand, then the question is, okay, what style should I pick without risking to be just left up here to hang high and dry on the Brooklyn Bridge? So certainly Scala is not a better Java. That's definitely not what it is, and I believe it's also not a Haskell on the JVM. I think that's better left to no doubt forthcoming implementations of Haskell on new platforms. I very much like Haskell, but Scala is not the same language. So what is it then? So I think it's sort of something that will emerge. I think there will emerge a new fusion between function and object-oriented, just like in the end, object-oriented and procedural programming also sort of fused. It wasn't really an antagonism. Object-oriented programming simply absorbed the procedural paradigm, and I think here we will sort of absorb the core features of object-oriented programming into functional programming. So, with that said, we still need to pick a style. So what I have to do now is give you a very personal point of view of some of the things I have been struggling with, where I said, well, what kind of guidelines can we give? Also, what kind of questions did I pose myself? Should I write things in this way and that way? How do you trade off, do the trade-offs between things? So what I'm going to do is I give you just 6 general suggestions of what I think is good style guides, good ideas to take with you when you program. And then I'm going to talk about 6 possible trade-offs one can make in one way or in another. So suggestions. The first one is really pretty obvious and pretty clear, but nevertheless, I think we have, I should say it, I think the most important one is always keep it simple. And since I talk about simplicity, I guess quite a few of you have seen Rich Hickey's talk at Strange Loop last year. If you haven't, then you should. It actually explains very, very well what simplicity is and how it's different from ease of use. Ease is familiarity, and simplicity really is the straight line. To go from A to B in a straight line without entangling a lot of different things into one complex whole. So complexity comes from complecting, and it has to do with essentially putting different concerns into a single thing and then having to manage too many different concerns. Simplicity means you can separate your concerns. Wherever you can do that, do that. And I couldn't say it better than what Rich Hickey did. So if you are unsure about this, then just look at his talk. So the second thing I want to say is that naming is very, very important. So here's something that I believe you shouldn't do. So that's sometimes stuff that I see sometimes. So that's an expression, and well, it's all very interesting what it does. Yeah, well, amazing what he can do in a single statement, right? But it doesn't mean that you have to do that. And I actually believe that, yeah, it's probably not a very good thing. Whenever I see code like that, I said, well, there must be a better way. So what would be a better way? So the better way is actually hard. That's why probably it wasn't done that way. Better way is to say, well, we need to find a name. Whenever an intermediate result is important, you should find a name for it. And that takes sweat. To find a good name for these things is not so easy, but it's important, and therefore I think it's important to keep that in mind, that one should invest the time to find these names. So I just took that and I tried to reorganize that, the same expression, but now I broke that out into a val that I said, well, sources is something where I go over the raw class path. And then I define what my workspace root is, and then I have a function that gives me for every entry the files that correspond to the entry, and then at the end I go through my sources and I take the files for each entry and I flatten it all. So now it's sort of halfway understandable. And what's very important here, and what I believe when you come back from a Java background, you don't immediately reach for that, is that Scala makes it so easy to put not just vals but also defs in line, right? Whereas in Java and in most other languages, it's a big deal, a new method. Well, I have to put that somewhere else in my class. I have to write a doc comment for it. I have to write all these modifiers, what it should be, private, final, whatever. And then there comes this body. So a new method is what, 20 lines minimum, something like that, maybe 10. Maybe you can squeeze it in 10. So people don't usually do it. They write inline code. Or the resistance against doing that is much, much higher. And in Scala, it's so easy. Just write the def right where it is, inline, and you're done. So note that I wrote a def, let's say, for workspace root. I could have written a val, but I just wanted to stay faithful to the original expression that maybe it could be that the iterator is mostly empty, so you don't want to uselessly compute, let's say, the workspace root when you don't need a file that works on it. It might be completely off in this example. I haven't looked at the code too much. It was just how the original one was written. But often it is the case that you say, well, something I don't necessarily want to evaluate that now. And then you have a choice. You can either make it a lazy val, then it's even cached, or if it's not a big deal, you just make it a def, and you're done with that. So I think it's so easy to do it, and often it's overlooked because, on the other hand, it's so easy to cram a lot of stuff in one huge, impressive Scala expression, right? In that sense, Scala can be used like APL, and that is quite impressive, and it's sometimes tempting because it's, yeah, this combinator, I just throw it in the same line and I'm done. But for long-term legibility, I don't think it's very good. Number 3, prefer functional. So I don't think I should, I need to expand much on that. I mean, we all know Scala is a functional language, so look at the side effects, what they could cause, what side effects can cause. Prefer functional. So that means, of course, that by default you should always reach for a val, not for a var. Reach for recursion or combinator programs, not for loops. Use immutable collections. Concentrate on how you transform things rather than create, read, update, delete loops and these sort of things. But on the other hand, Scala is not Haskell, so we are not 100% dogmatic about that. I also fully realize that sometimes it's just, there are also reasons why you want to deviate from that. Sometimes Mutable gives you better performance. It's undeniable. So if you need that for your code, and you have to convince yourself that you need it by, for instance, profiling your application first, then it might be a good fallback to do that. And sometimes, but actually not that often, it also adds convenience. So rather than standing up here and say, never use a var, it's probably good to just look at the cases where I would say it's okay to use a var. It's don't lose sleep about it. So why are people against state? What's the problem with state? So I think the main problem with state has to do with complexity, because state acts essentially as this medium where lots of different parts of your program interact in ways that you don't make explicit. It's a temporal order of effects. This guy assigns a variable, this other guy sees the new value. It's not something that's made explicit, let's say, as an input or output argument of a function. So that's the main reason why it's complicated, why it's complex. And that also means that essentially the wider the accessibility of state is, the more problematic it becomes. If state is local to your block or to your method, it's actually not a big deal. So local state is actually much, much less harmful than global state. So here's an example where local state might even be preferable. So here, what I have here, I picked that somewhere from the class file reader, I think. I say interfaces is some parse class header. And then I say, well, if I find that the thing is an annotation, then implicitly add class file annotation to my interfaces. I can do that, but it's a var. Oh my God, it's a var. I've written a var. Should hide behind. Well, I should have written, some people say, or could have written, something like this. I could say, well, let's make it a val, parsed interfaces. It's parse class header, and then say interfaces is, if it's an annotation, then parsed interfaces plus class file annotation, else simply parsed interfaces. But I mean, guess this is longer, and it's not necessarily clearer. Longer takes more time to read. So do I say, well, do away with that, always use vars? No, I think it comes down pretty much to the second point, and that's a point with naming. So what the functional version here forces me is to invent an auxiliary name for parsed interfaces. And that might be, depending on how my application is structured, something very good that I give this thing a name, or it might be just an annoyance, because in the end, I just want my interfaces, and I don't want to jump through the hoops of lots of different temporary names that I immediately throw away. So I think here, I believe you can have style guides in both directions, but my personal tendency would be not to be dogmatic about this, not to lose sleep if somebody writes var in this case. If it's strictly local in a method, it's quite okay. Here's another example for local, where local state might actually come in handy. Let's say you have a sequence of items with price and discount attributes, and you want to consume the sums of all the prices and discounts. When I go to my grocer, that happens. That will give me total price and how many rebates I got, and that's two different sums there. So, of course, we can write this inline like that, and that's the best way to do it. We can take the items, map the price overall, take the sum, and then do the same thing with the discounts. But let's say, because I want to be mean, I want to force you to do the same thing with just one traversal. Maybe I say items is an iterator. You can use it only once, afterwards it's gone. Or I say this thing is huge, I have a huge shopping list and I don't want to traverse it twice. So how would you do that? Well, if you look at the functional toolbox, then I believe the canonical way to do that would be to use a fold. Fold is like the universal tool. You can express basically everything with a fold. So let's use a fold here. So we would say total price and total discounts is a fold left over my items, and then essentially I start with 0 and 0, and then I go and I give you back a pair where I add the item price to the total price and the item discount to the total discount. But it's all rather entangled, right? I wish I had do we have a laser point? Oh yeah, we do. So, for instance, the initial values 0, 0, they are actually, they thread through this thing here that you say, well, that's where they first are, and then they get threaded through the fold left, and then they end up here. Not quite intuitive to see how values flow and how you add them. So if I compare with the imperative version, then that would be this one here, where I say total price, total discount starts with 0, and then I go through my items and I just add the price to the total price and the discount to the total discount. I believe that's actually something that here would be clearer. So if people say, well, if I have a complex thing, let's say several different quantities, and I want to tie them together with a fold, if somebody picks for a loop instead, I won't condemn that person. I think it's perfectly fine to do that also. Okay, so one thing then, nevertheless, where we have to be much more careful than what I told you before, were mutable objects. Because a mutable object tends to encapsulate global state, or rather, the state persists for as many different points in my program that can access this object directly or indirectly. And encapsulate sounds good, but it doesn't make the global state go away, after all. So it's still a lot of potential for complex entanglements. So when is an object mutable, you might ask, because that's actually very, very important to get that straight. So you could say, well, is an object mutable if it contains vars? Well, not quite. So here's a counterexample. I have my buffer proxy. It takes an array buffer. It has a put method, just forwards to the buffer. It has a length method, which is the length of the buffer. So it could say, well, is that object mutable? And I would say, yeah, of course it is. Because after all, it just serves as a front for another object, which is an array buffer, and we all know that that one's a mutable object. So you can't hide by just forwarding to something else. Good, so maybe we should just count mutable structures as vars and be done. Well, it's not so easy. So what about this then? So here we have a class memo, and it takes a function as values, and it has a a local variable, a local value memo, which is a weak hash map, a mutable weak hash map, and the apply method then does a get or else update on this memo hash map. So it says, well, if it's there, then take the value in the hash map. If it's not there, then use the function that you got provided, the function here, and update your map with that and return the value that you updated it with. So is that a mutable object? What do you think? Mutable? Who thinks it's mutable? Who thinks it's immutable? Okay, so yeah, it was a trick question because the answer is it depends. So the correct definition of mutable is that an object is mutable if its functional behavior depends on its history. That means the things that I've done before with the objects, the methods I've called before with the object. If that can influence the further behavior of the object, that object is mutable and needs to be handled with care. So the question then is memo mutable? So if I pass only functions like this one here, pure functions into memo, then the functional behavior doesn't change, because after all, what happens is that the second time I call apply on this memo thing here, I will simply get the pre-computed value of the first time I applied the function. And if my function gives me back the same result every time, then that first result is guaranteed to be the same as if I recomputed that function. So if I do that, then in fact this memo object will not depend on its history, at least the functional behavior doesn't depend on the history, so it is immutable. It might still run much faster the second time that I call it, but that's intended, and that doesn't enter into our definition. Okay, but then I have another situation here, and now I create a new version of memo with another closure, and that closure actually increments a global counter, so there's my variable, and returns its value. So that second version then, I would argue, is in fact mutable, because if I call it several times, then it would, I can observe the behavior. So if I, let's say, call this with an simple incrementation function and I apply it the first time, I would get 1. If I apply it the second time, I would get, 1 again. Right, so have I gotten myself on to thin ice here now? Yeah. Oh, yeah, of course, you could observe the counter, but let's say if the counter was private, then it still should be mutable, right? Oh, yeah. If this function was called from other ways as well, it would be mutable. The main effect, the main point is I wanted to illustrate that it really depends on being dependent on the history, and the fact that you simply cache functional values from pure computations in an object, even if that object then contains vars or mutable data structures, doesn't make it mutable as an object here. Okay, last suggestion is really a meta suggestion, and that's don't stop too early. So I think I've often experienced that I have a problem, I said, well, it's a pretty hard problem, and then I write a first solution, and then I write a second solution, and I'm very pleased with myself because I managed to cut it back in half, and the next day I come back and said, well, actually, I can do much better like that. Oops, let me just... Oh. And I find another way to make it even cleaner. And 4 weeks I come back and says, oh, how was I stupid? This can be much better written that way. And that's completely natural. So you might say, well, this is really frustrating. Why can't I have the first factor 10 solution the first day? So I think it's actually, we should see it the other way. It's a great pleasure to be able to go through this exercise to find a better solution multiple times for a piece of code. And I think we should embrace it because it's sort of part of the intellectual life here and part of essentially growing as a developer and as a programmer. So I think that's really important. And the important thing here is to keep being curious to see how can I improve this thing further? How can I make this thing even cleaner and more elegant and simpler? So keep going. Good. So those were the first 6 suggestions, and then I'm going to go through another 6, which are essentially choices that one can make, and where the answer is often it depends on what the precise situation is. And these are in part also choices that I grapple myself with. The first choice is infix operators versus method calls. So as we know, Scala unifies operators and method calls. So every operator is a method. Every method with at least one parameter can be used as an infix operator. So the question is, how do you choose between the two? So do you write items plus 10 or items dot plus 10? You could do both. Of course, I guess everybody here would agree you write items plus 10. Do you write XS map f or XS dot map f? That's actually a good poll. Who writes here XS map f as an infix operator? Okay. And who writes XS dot map f? Okay, the majority has XS dot map f. Interesting. If we push that further, then we could write, for instance, XS flat map fun filter not is 0 group by key fn, or we could use the dot method notation. I think for the first one, again, it's not controversial that I would say this one here is better, use the dot notation. But for the middle one, when do you go from one to the other? When do you stop using infix operators and go to the dot notation? That's actually a difficult one. So here I actually have changed opinion many times about this. So here I just propose one. You can, and I invite you to disagree with me and to discuss. We are here for 2 full days, and I'm looking forward to hear lots of different opinions about this and about also other style questions here. So I think the first rule is pretty simple. If the method is symbolic, then there's no controversy. You will always use infix. For alphanumeric method names, I believe one can use infix, and I typically do if there's just one alphanumeric operator in the expression, or where you would have put the parents anyway. But as soon as you start chaining, I would actually prefer the infix dot, and I've started to do that slavishly, to just say don't use chained infix, alpha infix operators, because they make things pretty hard to read. So I haven't put that on the slide, but imagine you would see just a sequence of words which says mapping, add, filter, map, second, flat map, third. I was a bit mean here that I used filter as an argument, not as a method name, because the way we key ourselves to say what are methods and what are arguments is that essentially we pattern match on the method names. But that won't work because you know your methods, but a reader of your program might actually not know that filter is a method, right? So because the first reader has to find these things out and will be completely puzzled by what this code is. So that's why I think chaining is important, is better. Chaining with dots is better because it's just much more explicit to say what is what. Choice number 2 is an old one for the Scala community. So if you've been around, then you know that this thing has been come up before and has been debated viciously. I think viciously is the right word, over the internet and in other forums. So do you pick alphabetic operators or symbolic ones? So since Scala unifies operators and methods, it says an operator is a method, and since operators tend to be symbolic, so can methods be. So it just means they're all different kinds of identifiers, which can be alphanumeric or symbolic. So how do you choose between them? Do you write XS map f or XS, well, I made that one up. I guess it's pretty clear you should write XS map f. Do you write vector plus matrix or vector add matrix? Again, I would say, well, if it's a plus, something that has a mathematical meaning, you write the plus. No doubt about that. That one is a personal favorite because I was really attacked over that one. Do you write XS fold left Z up or Z/:XS up? Who writes the left thing here? Yeah. And who writes the right one? Sorry. Yeah, that's sort of the danger in making up new notation because, well, I can explain to you why I believe the right notation is vastly superior to the left one. I talked to Sean McDermott last week, and he said he was always confused by fold left because he thought fold left, it goes from right to left. But no, it goes from left to right. So he thought fold left was, so fold right is the right one, and fold left is just the wrong one. So by which he meant fold right. So very confusing. Whereas here, the best explanation for this funny operator is falling dominoes. So you say, well, think of a domino thing. So it's a sequence of things, and you have an initial one, and then they all fall. So that's what this thing does here, right? You have the first value here, and then it all goes over there. And the other thing, by the way, which makes this much nicer is that if you visualize these things as a tree, as an operator tree, then, of course, the initial element, the z, is on the leftmost edge of it, and it is here in the infix operator, whereas in the fold left operator, it's actually to the right of the list, which is completely wrong. It's the other way around. So these are all the great reasons why I think you should write it that way. But you all disagree with me. Nobody writes it that way, and that shows that in the end, I think I was wrong. You shouldn't go up against overwhelming convention, and you have to be very, very careful with these new symbolic operators. A last one where I had much more luck, in fact, than with fold left was triple question mark. That was a win. So everybody likes triple question mark, I think. And people, after the symbolic operator debate, they were very, very skeptical. They said, oh, this was this disaster with whatnot. You should use undefined or something like that. Don't do new symbolic operators. But it actually turned out that triple question mark is a favorite of all the programmers out there. So what lesson can we draw from that? I think one should use symbolic only if the meaning is understood by your target audience and the operator is standard in an application domain. Or maybe you would like to draw attention to the operator. You would sort of say, well, this is really cool, and I have a good reason why it should be that operator, and I have a story. Because after all, the symbolic operators typically stick out more than alphanumeric ones, because alpha, you have a lot of words in your program, but if you have a new symbol, you say, well, what is that? And I believe that triple question mark, it was the ideal thing because it sort of was intuitively understood, and it definitely draws attention to the thing that you're supposed to fill in, much more than a word like undefined could do. But it seems the same margin of success didn't apply to my / operator. Well, maybe afterwards you all change your mind and we'll have some late success. But anyway, so go very careful on that one. Number 3, loop, recursion, or combinators. So often for some piece of functionality, one could use a loop like this one here, so that essentially looks at the first occurrence of something in a sequence that qualifies according to some predicate. Or you could use a recursion. So you have here a function that does the same thing. Or you could use predefined combinators. So here's the predefined combinator that would do that would be to say you go from 0 to length, you find the element that qualifies, and then that gives you back an option. So you get that, or else if the element is not found, you want to return the length of the sequence that you looked at according to the thing. So which of those 3 do you choose? That one is rather tricky, and I guess different people would choose different ways to express that. That's not the only example I have. So here's another one. Access mapf. Would you write that? Or this one here does the same thing. Or maybe this one here does the same thing. Ah, that was a trick question, right? Of course, you would use access mapf. Pretty clear. So here's another one. What does that thing do? Well, maybe I throw up the other ones, the other examples as well. So what that thing does is it produces the products of adjacent elements in a list. So it takes the first element and the second, produces its product, takes the third and the fourth, produces its product, and so on, in a new list. And here again, you have the combinator version, the loop version, and the recursive version here. And I believe there actually it's not quite that clear yet, again, what to do. Well, one thing is clear, that I believe the loop is the worst. You probably should never or hardly ever write a loop in these cases. But for the other tools, it's actually not so simple. So if you know your combinators, if you have grouped, and well, everybody has mapped, but grouped is something that maybe you didn't know, and you didn't know it only existed on iterators and not on other sequences, it maybe didn't come to you that readily. And furthermore, if your team doesn't know the combinators, then again, that's a problem, because this thing might be quite incomprehensible for your coworkers. So with that caveat, this is a very nice solution, but you really need to know the combinators. If not, then I believe that even though this is longer, it's much easier to grasp for the newcomers. You say, well, you go through the list, and then obviously there's something I do with the first two elements. That's what my pattern match does. So what do I do? Well, I multiply them, and then I go on with the rest of the list. It's pretty clear what this thing does for even a casual observer. So the third solution is easier to grasp for newcomers, and also if efficiency is a concern, then sometimes the combinator version will produce lots of intermediate data structures that take time. So typically, a tail recursive solution is faster than, or at least as fast and often faster than the combinator solution. And it's often overlooked. So I find with programmers, often sometimes they're stuck in the loop, or they are insistent on proving a combinator, on finding a combinator solution, but actually they want to just say, well, if it's too hard, just fall back to a simply pattern match and recursion. That's a very easy way out, and one that often is actually overlooked, and I think it's perfectly acceptable in many situations. So you could ask, well, why does Scala have all these puzzling choices? Well, combinators, they're done in the library, so in a sense it's not a fault of the language, but of course they're also the easiest to use. Recursive functions are the bedrock of functional programming. You couldn't do anything without them. Pattern matching is, of course, much clearer and safer than the tests and selections. And loops, well, loops is probably the toughest one. I guess the main reason is because they're familiar, and sometimes they're the simplest solutions. But if you were forcing me to throw out one of the three, then I guess I would throw out the loops. They are sort of the solutions that I believe you would use the least often. So recommendation, I guess one always tries to use combinators first. If you have the right set of combinators to do what you want to do, it's definitely the cleanest and safest way to get where you want to be. If this becomes too tedious because you have to do too many mental loopings to get there, or efficiency is a big concern, then fall back on tail recursive functions and use loops only in real simple cases, or when the computation inherently modifies state, then it might still be the best way to do it. Good. Number 4, procedures or equals. So Scala has a special syntax for unit returning procedures. So you can, for instance, write something like swap. It takes an array and 2 elements, and it would then, where's my, okay. And then you can simply, as you know, follow it with braces, and then you have the code there. Or, of course, you could use something that is the more standard style for all the other methods. You could take give it a return type of unit and use an equals there. So which would you choose? Actually, the official, semi-official Scala style guide says you should use this one here. And I believe the IntelliJ syntax checker also enforces you or says you should use this one here. Why Scala has both? I actually believe it's a historical accident. Initially, when we did Scala, I was really extremely concerned about not losing Java programmers over the first hurdles they had to take in this strange new language. And one of the first concerns was, well, we had the first programming examples that we explained to them, like a sorting routine. And the sorting routine is recursive, so you have to have a return type, and then you had to write sort : unit equals. And I said, oh my God, how to explain unit to a Java programmer? It will be the first thing where I'm going to lose them because they're so used to void, and then I have to go into all these details to say how unit is not quite like void and things like that. And it's just not a point I wanted to make. So that's why, unfortunately, I invented this notation of the procedure syntax, which in retrospect I think was actually a big mistake. Because it not only increases the irregularity of the language, but it also opens up a really bad trap that you want to write something like that. And that actually would be, well, it will give you a syntax error, but sort of what the parser thinks you're writing here is a refinement type. It says, well, this is unit, and then I do some additional definitions on my unit, and then the equals is missing, so the function doesn't have a body. It's an abstract function with a weird type, and then I would get some error that it says, well, this is not a legal beginning of a type, and the user used to say, what? Nowadays, things are much better. We really put a lot of engineering in the compiler to give you nicer error messages, and it's a huge hassle, but it wouldn't have been necessary if I just had been a little bit more prudent early on in the language design. So my recommendation is don't use procedure syntax. It's just was a bad idea from the start, and I think we probably are going to deprecate it at some point. So don't do more of that now. So that was an easy one. Here's a trickier one that was actually Jason Sauk who brought that to my attention. Private versus nested. So in Java, when you want to make something private, well, you write private, and that's the only way you can have any definitions that you hide. In Scala, you actually have two choices. You can make it private, or you can put it inside another method. Of course, that only works when the private entity method is only used from inside a single method, not several ones. But let's assume that's the case. So you have two choices. Which one do you pick? So here's one possibility. So you say, I have some outer method, and here I have an inner one called isJava, and here I use it. So do you write it inline like that, or do you write it as a private method like that? So I could here write isJava here, and a method like that. Which one would you pick here?
Does it say parameters by not having the deposit?
Good point, yeah. Here it doesn't. So here isJava is a method that doesn't actually capture any parameters.
What are the odds that you'll actually have a chance to use it later?
Sorry?
What are the odds that maybe you'll want to use that thing later would be the other thing?
From somewhere else, yeah.
So you don't need it anywhere else now, but you might. What are the odds?
True. That's another point. So let's assume we are pretty sure we won't need it anywhere else, and it doesn't capture any parameters. But it's, yeah. So definitely, if it captures parameters, then there's no doubt what you should do. So let's say if my isJava method actually would go to the owner here and use something with the owner, then if I would pull it out as a private method, I would have to parameterize it with this additional symbol. And that's something that I don't want to do. So I want to save parameters. Less parameters is always better. So that's clear. If you do not capture anything, then actually you have a choice, because then the fact that you don't capture anything is something that is actually important, again, to read the program. You say, well, I don't capture. The function isJava doesn't need anything in its immediate environment. So if I still write it in the environment, I have to do some mental parsing. I have to go through this method and says, well, it doesn't capture anything. It's OK. And if the method is short, like this one, I think that's also fully OK. But if it's long, it could be a problem. I often see code, a long method, 10 lines, 15 lines, or something like that, and it's inside some other method and says, well, does it have to be there? Or could I move it out? Maybe I want to make it usable for something else, but I don't know, not by just looking at the code. So my recommendation would be definitely, if you can save on the parameters, prefer the nesting. Also prefer the nesting for small functions, like 1 line, 2 lines, even if nothing is captured, because that's very easy to parse what it takes, and you don't want to pollute your larger namespace, but don't nest too many levels deep. So if you nest over 3 or 4 levels, that often becomes very difficult to actually mentally parse then what it is. Last choice. That actually brings us a little bit back to the first slides on object-oriented versus classical programming. Pattern matching versus dynamic dispatch. That's one that always also is always a thing that often people go back and forth on that. So here you have a hierarchy of shapes. A class shape and some subshapes, a circle and a rectangle and a point. And you want to write a method to compute the area of these shapes. How do you do that? Well, one way to do it would be to do a pattern match. So you have a single method area, and it does a match on all the different shapes that you do. The other possibility would be to actually put an abstract area method into the base class, and then to put a concrete one into each of the subclasses that overrides the abstract one. So which one do you choose? Do you choose the object-oriented way to do essentially dynamic binding, dynamic dispatch, or do you choose pattern matching? Yeah, that's right. So it comes down to the expression problem. And the expression problem has to do with extensibility. So first, why Scala has both. So pattern matching is essentially the functional inheritance, and it is extremely convenient in a lot of cases, definitely if you work with lists and if you work with many other things as well. And dynamic dispatch is the core mechanism for extensible systems, so that's why you have both. But for instance, it's a big question that we face in the Scala compiler all the time. Do you write a single method that does a pattern match over all the possible kinds of types or trees that you are dealing with, or do you put these methods into the individual types or trees? So the recommendation would be that it really depends whether your system should be extensible or not. If you foresee extensions with new data alternatives, then you are essentially forced to use the object-oriented method. That's why object-oriented programming was invented after all. It was invented for that, to essentially give you the ability to add new alternatives to your data. If you foresee rather adding new methods later, then again, it's a no-brainer. You don't want to add these methods every time into all the different classes that you have. You want to concentrate the methods. You want to use the pattern matching version. If your system is complex and closed, then I believe you should also use the pattern matching version. And that has to do a little bit with spaghetti code, because in the end, a lot of overriding of methods in many different base classes is a symptom of spaghetti code. That means that your thread of control is very non-local. You have a call, and then it very much depends on the actual runtime type where you will actually end up with. It's very hard to track, and you might easily overlook a possible implementation that might violate all the assumptions that you have about your methods. If they're all in one place and you do pattern matching on that, it's actually much, much simpler. So I had been involved in the Scala compiler, and I must say I did a gradual shift to say from sort of a mixture of object-oriented and pattern match, and nowadays I write much more the pattern matching kind than the object-oriented kind for that. So what if you want to extend in both dimensions? That's actually a tricky one. So one way to do it, you could do it, would be to have essentially combine a pattern match and an inheritance. So you could have a shape handler class that has an area method, so put the method in the class, and then if you have some extra shapes later, you can actually have a subclass of that without changing the code, and you can have a new area method that handles the new cases, like here a triangle, and if it's any of the old cases, it can actually forward to them. That's the question. What to do if you extend the system in both dimensions has been famously known as the expression problem, and it's actually called expression problem because the categorical example were expression trees, so the trees of a compiler where you might want to add new kinds of trees, new kinds of expressions, or you might want to add new operations that you work on these, that work on these expressions. So we are at the end of the talk. I guess I have shown you lots of choices that maybe left you puzzling. And that's, in a sense, natural, because I believe this confluence of object-oriented, imperative, and functional breaks a lot of new ground. People haven't really done that before a lot, and it means that a lot of new conventions will have to be formed, and I think are about to be formed. My main advice, if I should just give you these, is to keep things simple. Try to find good names for these. That's essentially half the success already. And have fun. Have fun in writing code, in improving yourself, in trying to find better ways to do the same things. Thank you. So now comes the fun part. I believe we're going to have more drinks, and there's going to be some music, as Sushila said, and I'm looking forward to mingle with you and discuss all the outrageous things that I've said now in the talk, and you can prove me wrong and propose to me other solutions. Thanks.